Hi and welcome to another lesson about memory. Today we are going to talk about some addressing rules of thumb. Objectives of this lesson. We will study some rules of thumb to verify our address calculations. This is basically more of a philosophical lesson. We are not going to see so much code. I will just present some important idea about addresses. Understanding addressing. Addressing can become tricky. Let's look at an example. In fact, this is not a very advanced example. Add DL, byte, ESI plus EDI. Now, by looking only at this instruction, could we infer something about what is ESI and what is EDI? Probably we can't know everything, but can we extract some information about the relationship between ESI and EDI? This is an important question because if we could, it will help us read code and maybe even write code. Let's consider years first. This might be surprising, but I want to begin with years. Let's look at the 2 years, 1992 and 2014. It doesn't make sense to add those two numbers. The result will be something that we don't know what it is. We could subtract them though and get a meaningful result. We are actually going to get the amount of years that has passed between the first year and the second year. Another example, we could add 5 years to the year 2014 to get the year 2019, which is a meaningful quantity. We make the following distinction. There are years and there are intervals. Years are, generally speaking, big numbers, and intervals are, generally speaking, small numbers. This is not an absolute definition because we could, for example, take a very long interval, for example, an interval of 3,000 years, and add it to the year 2000 to get the year 5000. But only generally when we think about it, it would be helpful to think about years as big numbers and intervals as small numbers. Examples. The year 1992 is of type year. As opposed to this quantity, the quantity 5 years is of type interval. Some arithmetic using those two types of numbers. A year plus interval equals year. As an example, 1995 plus 6 is 2001, which is a year. An interval plus interval equals an interval. For example, an interval of 3 years plus an interval of 5 years is a total of 8 years. Year plus year results in a meaningless quantity. For example, 1992 plus 2014 results in a meaningless quantity. We don't have any kind of meaning for this kind of result. And finally, year minus year results in an interval. For example, 2012 minus 2005 results in an interval of 5 years. Addressing. Address arithmetic. Just like we've talked about years, we can talk about addresses. In addressing, we distinguish between big numbers and small numbers. Addresses are considered to be big numbers, and offsets are considered to be small numbers. Again, there might be a big offset, an offset that looks like something big, but we just use the words big and small as a general notion. It doesn't mean that the number is actually small or big. We just treat addresses as big numbers and offset as small numbers. Now we have arithmetic rules of thumb for this kind of definitions. So we get that big plus small equals big, small plus small equals small, big plus big is meaningless and big minus big equals small. These rules correspond exactly to the rules that we had with the years. Those are the rules with the years, which looks exactly like the rules with the big numbers and the small numbers. Just that we take big numbers to correspond to years and small numbers to correspond to years intervals. Let's look at a concrete example after all these talkings about years. We've already seen this code example. This code example just reads the field y from a point that was declared in the data section. We already know there is more than one way to do it, but this is just one example of how to do it. Let's look at this result, my point plus pnt.y. This results in an address. We are sure about it because we use this quantity to refer to the memory, so this must be an address. We also can see that my point is a big number. We can see it here, it is a label and it represents the address of point in memory. pnt.y is a small number or an offset. We know that because we really know the value of pnt.y. It equals 4. We can see it from this struct definition. So we conclude that my point plus pnt.y is a big number, as a sum of a big number and a small number. We get that this quantity is an address, a big number, which is composed of a big number plus a small number. And by the way, using those rules of thumb, you will know not to do something like this accidentally in your program. I want to refer to the example that we had in the beginning, add dl byte ESI plus EDI. ESI plus EDI is an address, or a big number. We know it because we use this quantity to refer to memory. Hence, one of ESI or EDI must be a big number, and the other number must be a small number. We could find out which is which from the rest of the code. We cannot infer everything just from this line, but we could know that one of ESI and EDI must be a big number, and the other one must be a small number. And why is that? It can't be that both ESI and EDI are addresses, because big plus big results in a meaningless quantity. It also can't be that both ESI and EDI are small numbers. That is because small plus small equals small, or maybe offset plus offset equals offset. We can't get an address from two offsets. Summary. Use the rules of thumb to verify your address arithmetic. Big plus small equals big. Small plus small equals small. Big plus big is meaningless, and big minus big equals small. For every number related to addressing, ask yourself, is this a big or a small number? A final note, remember that these are just rules of thumb. This is not how you build your programs, but if you are, for example, a bit tired when you read some code, you can always use those rules of thumb to make sure that you understand what you see. You can also use those rules of thumb as a sanity check to look at your code and make sure that you write meaningful things. If you see, for example, that accidentally you add something big with something big, you should expect that something bad is going to happen, because big plus big has no meaning in the realm of addressing. This is what I wanted to tell you about rules of thumb of addressing. See you next time.